Hello and welcome to this is episode 9 of TGI Kubernetes. So we're going to continue today. The plan is continue to write the controller that we've been doing in the last couple of episodes. So I'm really looking forward to finishing that up. I was thinking about it like after this we're going to have some code, and I was thinking about writing some of this up and maybe doing a blog post about it so that you don't have to watch 3+ hours of me flailing around in an editor to get to the meat of things. But first of all, sort of little mic check. Can everybody hear me? Am I streaming? You never know. I feel like I'm talking into the void. It's always a little tricky to do this stuff. Let me know. So I do want to go through some sort of quick notes of what's happening around the Kubernetes world. Hey, Roland, Gregory. Good to hear that I'm coming through. So I do want to go through some notes on sort of what's happening in the Kubernetes world. There's always exciting stuff going on. And so if you folks have questions for me about what's happening, also shout it out. It's a good way to start these things off. So the first thing I wanted to talk about is Heptio. So the company that I started with Craig. Well, first I got to open my beer. So that's how it goes. Drinking Ranier today. It's a Friday. Why not? It's been a long week. So the first thing in Heptio news is it's a company that I started with Craig McLucky. And our goal is to bring Kubernetes to wider audiences, including enterprises, and really sort of bridge that gap between how, the folks who've been involved in the community, who've been involved in this world, how do we think about this stuff? How do we actually bring that to people who haven't necessarily been immersed in this world? So that's one of the things that we're doing there. So as part of that, so the big news for us is that we announced a new round of funding. So we're going to be around for a while. So this is our Series B. So you can go and look at the news articles on that. There's something up at blog.heptio.com. Which is great. So that's exciting. But it means that the real work is still starting, right? Because if you're taking money from venture capitalists, that means that you haven't convinced all of the customers that you want to convince yet. So, but it's definitely a good step on our evolution as a company. So that feels good. And thank you, Steve, for the congrats. I appreciate that. And then as part of that, we did a little bit of a rebrand for Heptio. And so let me show, like we got a new logo. Well, it's the same logo, but now we added sort of some color gradients to it. And we're doing this fancy thing where we have sort of 3 different gradients, and the website will actually rotate between them. And our website is no longer awful. It's no longer sort of my first theme on Squarespace. So definitely thank you to all the folks who put in the hard work for defining the branding and getting the stuff out there. So that's really exciting. We look a little bit more professional now. So that's great. There's a little bit more detail about the projects that we're working on here also, including some of our teams and our services, and we're going to be continuing to add to this over time, obviously. And I also changed, if we go back, let's see, if I go back to my face here, you can see like the title card here. I actually changed the title card for TGIK to have our new logo. We used a different typeface there too. So that's exciting. Let's see. So other exciting Kubernetes stuff that's going on. I'm trying to think. I don't think anybody's made any big announcements this week. So I don't think there's anything super critical to discuss. Let's see. So MezosCon has been going on, but all the big news with relates to Kubernetes happened a little while ago. So I think we've already touched on some of that stuff. In the larger CNCF world, the Envoy as a project has now been accepted into the CNCF, and so that's really exciting. I think Envoy is a really great project, and huge fans of the community there. It's one of the building blocks of Istio, and so if you watch the Istio episode of TGIK, you got a little bit of an idea of the role that Envoy plays there. So yeah, so there we go. Any other questions? Throw them at me. I really like to see this stuff be interactive, so let me know. But let's jump into it. So let's start with if you want to follow along with the code from where we were at before. Let me switch back to the screen. We can go to github.com. Joe Beda TGI controller. So this is the repo where I checked in the stuff that we did last week, and we're going to continue with this. And so the goal of this controller, and I need to write a better README at some point, is I just wanted to show the simple flow of how so much of Kubernetes actually works. Oh, any breaking news on 1.8? 1.8 is, so Roland was asking this, 1.8 is percolating along. Let's see, I haven't been super involved in all the sort of day-to-day release planning stuff there. But from what I've seen, things to be look to be going on track. So, you know, I haven't seen any sort of summaries of the like drafts of the release notes coming along. I think that's when things really get interesting, is once you start seeing those release notes. Now you can start getting the scope of what everybody's been doing across the project. And so looking forward to that. And definitely as that evolves, that's definitely something that I'll want to talk about in these in TGIKs. Okay, so so I wanted to demonstrate sort of a simple, you know, how so much of the processes for how stuff works inside of Kubernetes gets done. And the controller that we're working on is a secret synchronization controller. So I'm going to try out my document camera here, and we're going to do a little bit of sort of diagramming here. But the idea is that, you know, I have my Kubernetes cluster, and then I'm going to draw some boxes, and these boxes here are going to represent namespaces. And let me make sure I get the name right. So we're going to have one namespace that's going to be called secret sync. Namespace secret. And then we're going to have a set of namespaces, which, you know, we'll call this target A, target B. Okay. And the idea is that we're going to have some secrets here, and we're going to have the controller, you know, so here's our TGIK controller. It's going to sort of, you know, take these, it's going to do a watch, and it's going to do a write to these. So it's going to essentially take the secrets that are in this exemplar namespace and then create those, mirror those into other namespaces. And the scenario here is something along the lines of, let's say that you have a cluster that you're using for a bunch of developers, and you have some sort of secret for maybe talking to a test database, and you want to make that available to all the folks that are running across that cluster. Well, you could actually just give everybody the password, but then they would have to go through and actually create the secret in their namespaces. And if you change the password, you have to synchronize everybody around, that type of thing. Or what you could do is you could do something like this, which essentially says, I want to, you know, distribute this secret across all these different namespaces. And the way that we're identifying which namespaces we want to target and which secrets we want to synchronize is with an annotation. So this is an example of how we can add some extra data to an object so that we can use the controller to go ahead and do that. Now, one of the things that I've been doing, let me switch back to my screen. One of the things that I've been doing each time is I've been bringing up a fresh cluster, and I've been, you know, tearing it down between each of these episodes. And so then I have to like sort of recreate the secrets. And so why don't we go through and sort of automate that a little bit? So I'm going to create a new test folder here called test. And under test, I'm going to create a new file, and I'm going to call this, let's see, is this under test? Create simple setup.sh. Okay, and so this is just, you know, me having a quick and dirty shell script. Here, I'll make this a little bit bigger so that folks can see it. Me having a quick and dirty shell script so that I can automate some of this setup for stuff. So the first thing we want to do is we're going to do cube control, and you know what? And what I'm going to do is I'm going to do it here. Cube control, create namespace, secret, sync. All right, that works. I just copy these things as I go. I'm going to do cube control, create secret. I'm going to super secret, call it SS for super secret. What did I call it last week? I don't remember. And then I'm going to do from literal, if I remember, user password. Oh, no, it's, oh, generic. So I have to, the type of the secret is generic. Oh, and then the syntax here is equal. This is why I do it live and copy that. So I'm going to go ahead and do that. But this doesn't have that annotation that says this is one of the secrets that we want to copy. So I'm going to do cube control label. Is it label? Annotate? Annotate. Secret SS. Oh, you know what? I made that secret in the wrong namespace. So cube control delete secret SS. Let's go here. We want to do create namespace equals secret sync. And let's go ahead and run that. There we go. Okay. And then I want to go through and I do cube control, annotate, and notate. And then what is the syntax here for this? Okay, these don't have any flags. Okay. So annotate, and we do namespace equals secret sync. And we're going to go, we're doing secret SS, and then the annotation that we're adding here is 80%.net, which is my personal domain, secret sync equals true. So that works. Okay. So now we've identified, we've created a secret and we've identified it with the annotation. Oh, Roland, you're way ahead of me. And then we want to mark which namespaces we want to mirror this to, because if you have, you know, we don't want to necessarily put the secret in cube system, for example, right? So we're going to go through and we can do cube control annotate and cube control annotate namespace defaults, because we'll make default be the target here. You know, you could do any namespace that you wanted to do. Oh, that's not the right. Sorry about that. I had the whole line here. Namespace default, and then the annotation is the same annotation here. So we're using the same annotation just to say this is part of the sort of secret sync type of world. Okay, so this is the things that we're going to set up here. Okay, now where we left things last time is that we actually had our program running in a one-shot mode. And so what it would do is it would collect all the secrets in the secret sync namespace. It would enumerate all the namespaces that we want to mirror this to. And then for each of those namespaces, it would enumerate all the secrets there, create or update all of the secrets that were that already exist, that were in the source secrets. And if there were any secrets in the destination that had the annotation but were not part of the source list, then we assume that those things got deleted. And as they got deleted, then we would go ahead and delete those in the target namespace. And so let's go through and run our program, and what should happen at the end here is that we create that super secret SS in the default namespace. So let's make sure it's not there already if I didn't screw stuff up. Cube control get secrets. So we're in the default namespace by default. There's no secret called SS here. So now if we do go run star.go, what this does is it's starting up and it says caches the sync, and I have a debug thing, and then it says on add default SS, And then I don't know, did it actually do the thing? We may have to, oh yes, and it went ahead and created it. All right, so here we went ahead and we synchronized things. So that's actually really cool. So now let's see if the delete path works. So let's go through, and what we're gonna do is we're gonna remove the annotation from this. And the way that you do this is you copy, it's like annotate, but you put a dash at the end, which says remove that annotation. And so now if we run the program again, it should say, oh, well, now there's a secret in default, but it's not in our template. And so let's go ahead and delete that. And so you can see that the debug output says that it deleted it. And we can go through and make sure, get secrets. And there we go, it's gone. So that's cool. All right. So let's go through and we'll add it back just to make sure. And that's great. So now we can run this in a one-shot mode. And so this is actually kind of useful in and of itself, right? We could turn this into a program and then we could say, well, every time you modify the secrets, you run this, it synchronizes everything together. But one of the sort of nice things about Kubernetes is that things are self-healing, because the times when you want to trigger this is like maybe you had a new developer and they have a new namespace, or maybe a developer screws up and they actually delete their secret and this thing goes ahead and re-adds it for you. That'd be kind of nice too, right? So, so let's go through and make this automatic. So now we're going to turn it from a sort of one-shot client program into a controller, and this is where things start to get interesting. Let's see. So let's go back to the, so what we have here, I'm going to shrink this just a little bit so I can see stuff and close this. Is here we have the controller, and we had a whole bunch of scaffolding left off from the first time around. But what essentially we do is we have the informer. In an informer, oh, it looks like my video froze. Is this thing doing, I thought I turned off like go auto build because that was sucking all my CPU and causing things to screw up. But okay, but essentially what we have here is we have an informer, and what this is doing is it's letting us know every time we go through and we add a secret. Add, update, or delete a secret across our entire cluster. So that's what we're going ahead and doing here. And this thing is building. What is it doing? I thought I had, I'm sorry, I'm going to try and figure this out because it slows everything down. So if we can go save, there's like a go build on save. I have this set to off. Yeah, it is set to off. Auto build is false. I don't know what the heck this thing's doing. It's running some sort of thing when I hit save that's sucking up on my CPU and slowing down video, but I'll have to work on that later. All right, so essentially what we know here is that anytime any secret in the system changes, we get a callback, right? And that's with the secret informer. And then we have breakout functions here for on, update, on, delete, and on, add. Those are kind of useful, but the truth of the matter is that we don't really care what changed. We just want to know that when something changed, we want to go and actually update things. So I'm going to actually simplify this stuff a little bit here. And I'm going to go through and we're just going to do, let's see, we're going to do some logging because logging is always useful. So we're going to do secret add of the obj. Oh, well, we can get the key for the thing, right? So this is, oh man, that's right, because this thing, okay, so let me show you what's going on here. So what happens is that we actually get the object here, but when we log it, we want to log something that is like, we don't want to log the whole object, we want to log, like, say, the name of the thing, right? And so there's this helper function here, which is meta namespace key func. And if we look at this, this takes the object and actually decodes enough of the object to actually get a useful name out of it. And so if we go to the definition of this, it goes through and it looks, oh, is it an explicit key type of thing, which is a type? that can be used with some things. Then it uses that. Otherwise, it does a bunch of like this meta accessor thing and gets the metadata out of it and looks to see if it has a namespace and constructs a whole a string out of that thing. And then there's a chance where this thing can throw an error, which is kind of annoying also. Let's see. Let's go through, and I want to shorten up this code, and we don't necessarily need to do the meta namespace here. So what I'm going to do is I'm not going to bother. I'm not going to bother actually doing that stuff. So I'm going to just go through, do secret added, and I won't actually have a thing there. So we'll do print, and we'll go through and we'll do secret updated, and then we'll go through and we'll do secret deleted. And then I'm going to have a function here which and I'm going to call this schedule sync. And this says, hey, at some point in the future, I really want you to go through and based on this poke, run our program to actually go ahead and do stuff. Schedules, I'm going to call it secret sync. We haven't written this one yet, so let's go ahead and we'll grab this, and we're going to call that on each of these things too. Okay, Timo says, I don't have a workspace setting override. No, I don't think I have a workspace setting override on this. So it may not be building, it may be like going through and doing like Godoc stuff and stuff like that. So that may be what's sucking all the CPU too. Okay, and so we'll go ahead and do that. So now what we do is like every time a secret gets added, updated, or deleted, we're going to call this function. We're doing that for secrets, but we also want to do that for every time a namespace changes also, because if we add or remove namespaces, that matters. Okay, he says maybe Docker is running. I don't think I'm running Docker right now. That's what Roland's guessing. So I don't think I have Docker running. Yeah, I don't see it. I'm looking up in my bar. I don't know. Well, I don't want to spend my time debugging that right now. I'll have to do that offline sometime. Okay, but now we have the secret informer, but we actually want to have the namespace informer, same thing. Informer, and these will all be the same, but we'll do namespace added, updated, namespace deleted. Okay, so same sort of thing. So this is essentially like if anybody does anything to any of these objects, we want to actually go ahead and schedule things. Now, one of the interesting things here is that we could have this schedule secret sync actually be that big function that we wrote that does the same. Oh, and I can delete all this stuff. So let's delete some code. It always feels good to delete some code. And we have this, and this stuff's left over here, this handle secrets change. We could do this at some point where we filtered being like, well, this secret couldn't possibly matter, so I'm not going to bother doing it. Because right now this will be a little bit aggressive on triggering this stuff. But I'm going to delete this code just for simplicity. And I'll add a to-do up here. Go to-do, only schedule sync if it is a secret that is either that has or had our annotation. So we could do some sort of like filtering of that stuff. And same thing here, to do only schedule sync if it is a namespace that has or had our annotation, or the secret sync source namespace. But I'll go ahead and make sure that we're not, I'll make sure that we're not, for simplicity's sake, we'll just ignore that for now. Go ahead, we have schedule secret sync, And then we have the do sync. So we have the do sync does the synchronization synchronously. It'll just do it right then and there. So what we could do is we could go through and actually call do sync anytime we got one of these notifications. But that would actually cause a problem. And the reason why that would cause a problem is because as the controller is coming up, it's actually going through, if we look at the debug output here, you see we get all the ads as the thing is actually coming up because it's discovering things. And then at some point we're like, oh, the caches are synced, right? So we only want to do this after the caches are synced, right? So we want to delay doing the synchronization because as we're going through and doing the synchronization, we're reading from those caches. And so we don't want to find ourselves reading from caches that aren't fully populated yet because that can kind of cause things to churn a lot before everything goes ahead and settles. The other thing that we don't want to do is we can batch this stuff up. If we get a flurry of changes, we can wait until, do a bunch of stuff, get a bunch of changes, and then do a bunch of stuff. And so we can do this with separate Go routines and just say that like, hey, at some point when you're done with the current synchronization, do another synchronization. So if there's synchronizations happening while we're synchronizing, we can go ahead and do that. And so it reduces the amount of noise if we actually go ahead and schedule this thing. Now, a lot of times what you'll do is you'll schedule it based on some sort of key object. And so there's a whole bunch of support built in some helper libraries that come with the Kubernetes client Go library that helps you to do a rate limited update based on some sort of key where you'll only do an update for that key once at a time, right? So you sort of coalesce based on that key. And so that key that we were talking about earlier for decoding, a lot of times that'll be the thing that you'll use as your key for that queue that you're going to be decoding from. But because we're just sort of synchronizing all the everythings, and that's the function we have, we don't need a key. And so what I'm going to actually do is I'm going to actually create a new constant, secret sync key equals do it. Doesn't matter what it is, it just has to be a string. And so that'll be our key. And we're going to reuse some of the rate limited queue support that we have. And let me go ahead and I'll go ahead and find, so let me close this file. And I have a cheat sheet here. So this is I don't think, so Andy, who's one of the Kubernetes developers who works here at Heptio, has been working on a blog post that he hasn't published yet. And I stole some code from that blog post, and that's sitting here in this temp here, where he essentially builds a controller that uses a CRD and does all the code gen stuff around that. So that is coming in some shape or form. But what we're going to do here is we're going to do this rate limiting interface. It's part of this work queue interface, and we're going to actually make that be a new thing on the controller. And it's going to be a queue that'll only ever have at most one item on it, but we get to reuse a bunch of code when we do that. And if we look here, there's like add rate limited forget, and then, oh, number of requests. Is that really? Number of requeues. Okay, yeah, so there's this thing, if you get an error, you can go ahead and requeue it so that you can retry it. So that's, I thought it was number of requests. No, it's number of requeues. How many times have you actually gone through and put stuff back in there? So let's go ahead and we're going to look at the code that I stole from Andy's as of yet unpublished blog post. Where did it go? Temp.go. Let's see. So here we can see sort of the general thing here where he has the work queue, and then he has here this, he actually initializes the work queue. So let's go ahead and do that. So queue, oh wait, is it getting mad at me? So see my video stuttering as I hit save. Something's going on. Okay, so work queue. So it's a new, and this got, let's see, we pulled in the right library up there. So this thing is new named rate limiting queue, and we're using the default controller rate limit. So this is so that you don't actually pound on the Kubernetes controller as hard as you might. And then you have to give it a name, and we're going to call this secret sync. And the reason why you give it a name is it uses this name, I believe, maybe to create like Go routines and give them names, but it definitely uses it if you're like exporting Prometheus metrics out of it. And so that's one way that you can go ahead and identify multiple queues and collect sort of how much are these queues hitting, are they getting rate limited. It's one of those sort of debuggability mechanisms built into Kubernetes. So now we have our queue that we're using. I'm going to go ahead and save that. Let's see. Oh, my CPU spikes. I got to figure that out. All right, and so the next thing we do, oh, and then he has this sync handler, which is process widget. The sync handler, I don't know if we need that. Let's see if we need that. So what he does is that anytime I have an add, he goes through and he adds this with the queue, right? So let's go ahead, and the way that we're going to do that is that's going to be schedule secret sync. And so we're going to go ahead and we're going to add that to the queue, but we're going to use our secret sync key, because we're just going to have at most one item in the queue at a time. And so now what happens is every time anything changes in our cluster relating to namespaces or secrets, we're going to add an item to this queue if it doesn't already exist. So pretty simple. But now what we need to do, and you can see like pretty much what he does here is he enqueues stuff, is now we have to go through and we have to run the thing, because nothing's actually dequeuing this thing yet. And so this is where we actually get a little bit of boilerplate. So here we have a set of workers, the number of workers that we're actually running, and a stop channel to actually say go ahead and stop this stuff. So I'm going to go through and I'm going to go ahead and copy this particular function. And here we look at run. And before we were calling our synchronous do sync, we're going to go ahead and I'm going to delete the stuff that we have there. And what you see is that we have a wait group. Because generally you're going to have a set of workers. Now we're only going to do one worker this time because we're at most going to have one. Okay, oh, lint on save. Let's see if we have lint on save as my go lint on save. Oh, maybe that's it. Let's turn that off. Oh, maybe that does it. Vet on save. I don't want to do a go vet either. That's a little bit. Format on save I do want to do. I love my format on save. So let's go ahead and let's see. I'm gonna we're still spiking the CPU. Maybe it's not as bad. I don't know. We'll see. Okay. Okay, so what we're gonna do through is we're gonna do a defer function which will shut down the queue. And so the queue has a shutdown method, so we're going to tell the queue to shut down, and then we're going to actually wait on this wait group that says wait for all of the Go routines that we're going to spawn to actually shut down. And then we're going to actually say, okay, everything's done. And we're going to put that in a defer function, so that means that this will run at the end of the run function, regardless of how the run function ends. Here we're waiting for the caches to sync, and if I remember secret list, and you can pass a couple of them in here. Let's see. And so here we are waiting. Oh, and we don't want to use glog, so I used regular log here. Oh man, annoying. Okay, log.print. And let's do, oh wait, what am I doing? What is the keyboard shortcut for selection, find, edit, replace to log.print? Okay. All right, so here we are, timed out, waiting for the cache to sync. Because like if you're trying to start this thing up and like things aren't synchronizing, eventually you could time out. So we'll just go ahead and do that. And then finally the caches are synced. So what you'll notice is that we've as doing all that, our things will actually hit and we'll add our item to the queue. So we're pretty much guaranteed by the time we get here that our caches are synced and we have one item in our queue, but we haven't started up our workers yet. That'll actually, okay, Justin says I have build on save. Set up to, I don't know if I have build on save. No, that one I have off. You can see here's like the defaults and here's the current one. So build on save is off, so I'm not quite there. And then Timo's like, how large is the queue by default? Is it possible to run out of queue buffer? I think the queues are dynamic and unlimited. Let's go ahead and look. So here's new. So there's the rate limited queue, which is built on top of the base queue, and so what this has is it has the list of items, and then it also has a set of all the items that are in there. So that way you can determine whether an item's already in there when you go ahead and add it. And so these are the ones that you're currently processing, and these are the ones that are dirty and that need to be processed that are in the queue someplace. And I don't think that there is a limit. So let's look at the add function here. So there's some locking, shutting down. Go ahead and add it. We do a insert if it has it, and then we just do an append. So I don't think that there's any limiting on the length of the queue. So it may be, so there's like a delaying queue where it's like, oh, I want to do this, but I want to wait. So that way you don't start processing immediately. You sort of wait for a storm of changes to happen before you go ahead and process. This is the, let's see, this is the rate limiter. So there's a simple rate limit implementation here. Well, this is actually an interface built on top of the Juju rate limiter. But I don't think that there's a limit on the size of the queue right now. But the thing that you really want to control for, I mean, I guess you could run out of memory, but typically, like all the sort of number of objects in a Kubernetes cluster fit in RAM relatively easily because you're caching the thing anyways. So that's generally not the problem. The problem ends up being that you overload the API server by actually really hammering on it too fast, and then you start sort of a storm. And so that's why the rate limiting queue is probably the thing that you want to use out the gate. And if we look here, where's the default rate limit? It's in here someplace. No, I don't know. It's default, yeah, okay, rate limiter, default item-based rate limiter. So it's an exponential failure back off type of thing, I think is the way that it works. So there's some like sophisticated rate limiting, oh, sorry about that, rate limiting voodoo going on here. All right, so now we have this thing, and we're going to go ahead and we're going to start up the workers. But you know what? We only need one worker, so let's go ahead and actually do that. And this run worker will loop until something bad happens, and then it's using this function called wait util, which essentially runs things in a loop. If something bad happens, it goes through and actually restarts it. When this thing exits out cleanly, that's when the Go routine will exit, and it'll actually signal the wait group. Cover on save. Is there a cover on side? Man, there are so many options. And Go, is there a cover? No, that's false. So I don't have that. I don't think, I'll just mark it false to make sure. That's not doing it for me. I'm gonna have to, like, get out top or something like that while all right, so we can go ahead and do that real quick. So let's go through. Okay, we're yak shaving now. Obviously, Google Chrome is taking all my CPU. Oh, how do I sort by, now I have to figure out how to sort by CPU. Darn it. All right, no, I'm not gonna do it. We're just gonna suffer. I'm not gonna go down that rabbit hole. Okay. And so this actually says, does the run worker. If that thing fails, then I wanna actually wait a second, and then I wanna go again. And then there's this actual channel here that stops. And so it says, okay, when I get the stop channel, I wanna actually kill things and exit out. And then let's see, we're gonna need to copy, and this, You know, it's not so bad when I'm coding directly, but somehow when I'm doing this, okay, so we have a couple of functions here that we're going to collapse into one, and this stuff is not formatted well because I copied it from. So yeah, it's not so bad when we're not broadcasting. There's just something about broadcasting here. All right, so now I'm going through and I'm doing this run worker thing. What the run worker thing does is it calls, you know, process next work item. This says widget controller, but we're not a widget controller. We're the TGI controller. So this goes through and processes the next work item. The process next work item gets the thing from the queue. It then goes through and actually marks the thing as done because you always want to indicate that it's done. It goes through, it calls the sync handler with that thing. If we get an error out of the sync handler, then we go ahead and if it's successful, then we tell the queue to forget it. Otherwise, when we mark done, it actually gets re-queued. And so the queue has a bunch of sort of semantics. The queue has a bunch of semantics to be able to make sure that if something fails with an error, there's this default of retrying thing. So unless you actually tell the queue to forget it, it'll actually keep trying. And I believe it does failure counts on a per item and does rate limiting on a per item type of thing. So then we go through here and we want to report it and go ahead. Okay, you guys still have stopped vid or did it pick up again? Okay, let's see. Yeah, the format on save. I don't know if it's the format on save. Is it really bad, guys? Is the video... You guys still have audio? Oh. All right, how are things now? Are things better? Everybody says they have stopped video. Did everybody drop out on me? I apologize if that's the case. All right, I think I'm back. It says that we should be back. Let me go to the public view. Let's see, am I doing stuff? Yeah, so it looks like I'm there now. All right, video's back on. I'm sorry, guys. I don't know what's going on here. This stuff is always tricky. I think OBS crapped out on me because it went to 0 and it wasn't actually sending anything. Were you guys getting? I don't think you were getting audio during the time either, were you? So that's unfortunate. So let's turn format, even though it's my favorite feature. Let's turn format on save off too. And maybe that'll actually save us here. No, it's still doing something. What is it doing? Yeah, sorry about the blackout, guys. All right, so, okay, I'm going to debug this real quick. I apologize. We're all going to learn something here. I want to do the activity monitor. And you can see what's taking up all of my CPU. So here's the VT Decoder XPC service in OBS. This has got to be the thing that's actually doing the video encoding. And then it's scraping the Windows service. And then there's all sorts of random stuff. And I got Chrome running. I don't think so. Now let me go through and do a save. And we'll switch back to that when it's... Let's see. Code helper. Oh, now it didn't. Okay, it looks like maybe it's not. All right, now maybe it was the Go format. Let's turn Go format back on real quick. Oh, something. What do we got? Code helper. Now it's not doing it. Damn it. All right, I don't know. I'll have to muck with this stuff later. Okay, let's see if the video craps out now. Oh wait, it spiked again. Maybe it just spikes when I move stuff because that's do a bunch of encoding. All right, so where was I? Okay, so when we do the process next work item, we get the thing from the queue. It's the same key as we had before, but we also get a quit marker, whether we want to quit. We mark that thing as done when we're done regardless, but we can also go through, and if we're successful, then we want to go through and actually forget it. Otherwise, we want to report an error. And so this sync handler here is kind of generic, but what we're going to do instead is this is where we're going to call doSync. doSync right now doesn't return an error, but let's go ahead and actually have it start returning an error and plumb that through. And so here, instead of sync handler, we're going to call do sync. And we're not passing the key in because we don't care what the key is. If we go through and if everything is kosher, then we go through and we say, okay, we're going to forget the key. Otherwise, we actually say do sync failed with blah, and then we're going to pass the error. And then since we failed, we go ahead and we actually add it back. So we go through and requeue it. And so this is a little bit of boilerplate. If we took out all the comments, this wouldn't be quite so bad. But essentially, this is the thing that's running in the Go routine. And the reason why this is a little bit sort of overprotective is this is essentially our main loop of the controller is what's happening with these Go background tasks. All right, so this thing is going through and it's calling run worker. Run worker is actually in a loop calling process next work item. If this thing crashes for some reason, I believe, let's see, run worker. If it crashes, I believe it'll actually restart it. I'm not sure though. So I think it actually does grab that stuff. And then we'll actually go through and, okay, and then we have runtime handle error. So this is like some of the sort of error handling. So like when you get an error in a server, what are you supposed to do, right? You don't want to crash, you don't want to error out. You kind of want to report it and you want to be able to track those errors so that, you know, in your monitoring tools, you can actually see this stuff over time. So if we go to definition of this thing, it'll actually call, there's a bunch of sort of error handlers that you can install. And there's a default one here, which is a rudimentary error backoff, which goes through and I believe like logs things, but it makes sure that it doesn't totally spam the logs. Oh, and we still have a glog going on there. Well, definitely that glog will bite us in the butt when we try and compile. Where is it? Oh, no, it won't because we actually imported log.print. That's right, because it was marked error. Yeah, obviously we can switch to a better logging library, but that's we're keeping it bare bones for now. All right, so this will run the worker. It'll go ahead and do its thing. We'll get doSync failed. So here's what I'm going to predict. So we're going to run this, and after I fix my compile errors, which I'm sure I'm going to have some. Let's see. Yeah, after I fix my compile errors, we're going to have a problem. And the problem that we're going to have is that if you remember before, we took this shortcut where we were going to update the secrets and the target namespaces regardless of whether something had changed or not. And so what that means is that in the process of doing an update, we're going to actually trigger our thing to actually do another update. And so we're going to get in a continual update loop where we're going to continue to spam stuff. So it'll work, but it'll actually cause a lot of trouble on the API server because it's going to be continually writing a bunch of stuff and essentially running our stuff in the background. If we just wanted to run this in a continuous loop, that would have been an easier program to write. So let's go ahead and run this, and then we'll see that problem, and then we'll go ahead and fix that. So let's see how bad we are in terms of compile errors and stuff. Oh, hey, look at that. So this is like freaking amazing, by the way, is that I wrote this thing And the first time I ran it, I didn't get any compile errors. Like this is like, this is winning the game when it comes to when it comes to actually writing code. And I find this happens to me quite a bit with Go. It's kind of amazing. So that's actually really cool. Okay, so so it looks like, okay, so we did a secret updated, and we went ahead and we did that. And okay, so we didn't do the thing that I thought it was going to do. So let's put this in the background, and let's go through and we'll let's remove the annotation. Okay, and it says delete SS secret deleted here, and so Justin's saying, wasn't the queue manage some of that turn so you don't have a constant feedback loop? I think so, but I'm actually a little bit surprised here that this is what's going on. I got to be honest. It could be that if you get notified on an item while you're processing that item, it actually ignores the incoming notification. But that's an interesting question here, because this did not do what I expected it to do. I thought we were going to actually get ourselves in trouble. One of the things I'm going to do here is I'm going to exit out of this. Okay. Okay. And what I'm going to do, so we have caches are synced, work item, processing, do sync. So we actually are calling, there's no logging every time we actually do a sync. So let's go through and do sync. Oh, that's our here. Okay. Starting, do sync. And here we were panicking if we got one of these things. We'll just do return error. That's a heck of a lot cleaner. So let's clean this stuff up while we're at it. Sync namespaces. We were going through, and we should look at all those errors and see what's going on and make sure that we're doing the right thing there. So Justin says, so the block forgets the item though, and since we have only a single key, the cleanup at the end of the processing loop should be removing that. I think you might be right. I think the way that this is written is that if we get poked again while we're in the process of actually doing an update, it'll actually miss that poke. That's something I'm going to ask Andy about for sure. But let's go through and really understand the semantics of this stuff, because what we have here is we have forget indicates that an item is finished being retried. It doesn't matter whether it's for permanent failure or for success. We'll stop the rate limiter from tracking it. This only clears the rate limiter. You still have to call done. So forget is only a thing for the rate limiter. And we're calling done on it regardless of whether we actually handle it or not. And so let's see. So let's look at the interface here. There's no good documentation on this interface. So we're going to have to read some code. So when we get an item, we go through and we get the first item in the queue, we mark it for metrics, we insert it in the processing queue, and then we delete it from the dirty queue. And then when you mark done, we delete it from the processing queue, and if it's in the dirty queue, we actually re-add it to the queue again. And so this is actually built so that if you get an item added while you're processing that item, when you actually mark the item as done, it actually keeps track of it and causes it to get re-added. So I don't think your theory is what's going on here, Justin. I think that actually we are, if we get an add while we're in the middle of processing, that doesn't actually do what we think it's going to be doing. So let's go through and let's see if we can figure out why we're not failing in the spectacular way that I predicted that we were going to be failing. Okay, so here we're starting a do sync. Oh, we don't actually mark when we finish the do sync. So let's go through and do that too. Oh, you know what? I think I might know what's going on, but let's see. So do sync. So we'll go ahead and do that. Now let's go through. So we have that. Oh, what did I do? Okay, I accidentally cleared. Okay, so now let's go through annotate. We're going to set this thing to true. And what happened here is that we got the secret updated. We started the do sync. We got secret added. Starting do sync. Secret updated. Okay, oh yeah, so okay, so it does settle. So okay, I think what happens here is even though we are doing an update, whether the secret has changed or not, the API server doesn't actually trigger a new watch. And so there's an optimization in the API server where it notices when a change is a no op and it says, I'm not going to bother actually making that change. It's probably an optimization going to etcd. And so then this thing eventually settles. And so this here, so this secret updated is in reaction to the kube control annotate call. We start the do sync. That actually looks at all the caches and goes through and adds it to the default namespace. So this is the add to the default namespace. That causes another sync. That sync goes through and does an update. And that update, for whatever reason, tweaks something. And so then we get the secret updated. We do another do sync. It actually is going to do another update, but that update ends up being a no op. And so we end up exiting out. I believe that's what's going on here. So optimizations in the API server are saving us from getting ourselves into a notification storm. Let's go through and put a little bit more logging in here just to make sure that we know what's going on. So here we're going through, and when we do we'll either do an update or an add, and in either of these we're going to get an error. If we get an error, we'll go ahead and we'll print that. But like, let's go through, and we're not seeing that come in because we're not actually seeing an error. But our options are from syncing in namespaces to actually return that error. Or we could go through and chances are, let's see. So we can do if API errors.isRe. I think there was a thing that would categorize whether errors are retriable. Maybe I'm wrong. Okay, and Steve says, would adding a few more target namespaces help us to understand it by seeing more of the output? I think it might. New is unexpected object, is too many requests, is timeout, is not found. I think, let's go. Let's just enhance this error. Error adding secret blah to blah. Okay, and so the secret that we want here is let's just do secret.name to namespace with that error. Okay, so now we have a better error there. Here, we're going to do error listing secrets in blah. That's the namespace. And then here we're doing the delete let's just do so, and this is delete. And if we do error deleting, all right, I'm just trying to improve the output here so we get a better idea of what's going on here. Log up. And this is one of those things where a logging library with verbosity definitely helps because this is going to be too noisy for production stuff. Let's do, so creating doing namespace secret.name. And then we're going to go through, and here we're going to be like .printf scratch that updating yeah. Oh, and you know, my CPU's pegged again. Let's not talk about that though. That just makes me upset. And let's just try and standardize the way that we're logging this. Okay, so now we actually go through and we're going to see when we're doing the create, when we're actually doing the update, when we get an error saying, hey, the thing already exists, and when we're doing the deletes. So I think that should get us some more. All right, so let's play around with this a little bit and actually make sure it does what we want. All right. So now this thing is, okay, so secret added, namespace added. That's all what we expected. Caches are synced, finishing do sync. It says creating default SS, scratch that, updating default SS, and then it does finishing do sync. So there's what we're actually happening inside of a do sync. And so now let's go ahead and let's remove the annotation. And what we see happens here when we remove the annotation is that we get a secret updated. We start the do sync, we delete default /SS, we finish the do sync, we get a notification of the secret deleted, and then we do another do sync after that. That seems to be reasonable. Now let's go through and let's add the annotation back. All right, so when we do this, secret updated, starting do sync, and so we create it. We get the secret added, so that causes us to poke the queue again. We go through and we actually create it. No, we're going to update it. We get the secret update notification, and then we go through, and this time we actually do a create, we do an update, we finish the do sync, but we never notice a change because it ends up being a no up. So something along the way is actually saying, hey, I got an update, but the contents of the update were exactly the same of what I had before, so whatevs. And that's saving our bacon here. So that's cool. All right, so now let's go through and add another namespace like Steve is suggesting here. So we'll do cube control, create namespace, user1. We'll go ahead and do that. So what we find here is this is exactly what we expect. We get the namespace, we do a sync. It goes ahead, it does a, it tries to actually do a, oh wait. What's going on here? Create default SS, secret added, scratch that updating. It does a do sync here, but we're only ever creating default SS. It does it a couple of times before it actually realizes. So we probably still want to go through and do that optimization and collapse and not do an update if we don't have to, but something along the way is actually catching that and fixing it for us. Now let's go through and we'll do, so what it wasn't adding into the user1 namespace because we didn't add that annotation yet. So now let's go through and annotate namespace user1. And as we do this, look at that. It actually went through and, oh, scratch that updating user. Did it create it before? I didn't ever see it create user1 super secret. But cube control. That's what we expect. Okay, let's add user2. Cube control, create namespace user2. Now we should get secrets. We shouldn't see it there. Right. Annotate. So now we're going to add the annotation to that namespace, and look at that. There we go. But what's confusing me here is that it's doing a create, and then it's actually going through and actually doing an update on the thing. So I'm not seeing the first create of user 2, or maybe this is actually doing the thing, but it's, so that's confusing me a little bit. But it does seem to work. Maybe it's a bug in our logging. So here we're going through and we're creating the namespace. And we're saying if it already exists, then we go through and do that. Already, how is this API errors actually doing its thing? So yeah, so that means we're doing, it looks like we're doing the create, but the create is, let's do a little bit more debugging here. I always, okay, shell new split horizontally. Is that gonna work? Oh wow, I have, I don't know what's going on now. Okay, let me go ahead and do that. Okay, left over from a while ago. All right, so here we are, cube control get nodes. Is this, no, it's pointing at there. Okay, so export cube config equals cube control get secrets all namespaces. All right, so here's all the secrets that we have, and we're using cube control to actually watch what's going on here. And let's go through and let's create user 3 as our thing. Okay, so we get an add of the default token. That's exactly what we would expect. None of the other secrets seem to change. And now we're going to annotate user 3. And it seems to work. But we got 2 notes here, which says that it like created it and then something changed. So there was a create and an update of the thing. But I'm still not sure why we actually ended up seeing that error the first time. That's really fascinating. Something I'm going to want to track down sometime. I'll ask Andy, maybe he knows when he's around. But this is, okay, so where we're at now is essentially a controller, right? So, and I think this is a good pattern to follow, is that you write some code that essentially looks at, you know, what's happening with the world. Let me do it in a one-shot type of thing. And then you set up that code so that you trigger the one-shot whenever you actually see the changes that you want to have happen. Now, and then everything beyond that is really efficiency, right? So like right now, like we're having us updating things, triggering things. We are not as surgical as we probably could be because we're just going through and reconciling the entire world. All of that stuff is solvable problems. So you can start with a relatively simple controller that's a little bit overkill like this one, a little bit inefficient. And then you can go ahead and you can go ahead and then change that control over time and make it more efficient as you need to. Let's see. Oh, the last thing we can do is we can actually run this on our cluster. So let's go through, and I think I have to like start Docker up here. So this is definitely gonna tank my machine. Let's see. Oh, a new version of Docker is available. Remind me later. Okay. Oh, it's starting up. See, is it doing its thing? Yeah, okay. So I have like some cool makefile stuff here. Actually, let me, oh, wait, that was the wrong thing. It's that, okay. I can do make container. And then this is pushing it to, which registry is this pushing to? What do I have it set up to do? And this will do like different, okay, I think this pushes it to, I don't know, let's see. Oh, what happened? Unexpected package found type. Temp. Oh, I don't want that. Oh, this is my like, my extra directory that I don't need because now we're good. It was building all the everythings. I didn't want to build all the everythings. So this is essentially building this stuff cleanly. This is this make file was before we had the multi-stage Docker builds, and so it's kind of doing that stuff directly, where it's creating, running the go build in a Docker container, and then taking the binary out, and then creating another one. So you could probably do this with the multi-stage stuff now. Let's see, make push. Let's do that. So Steve's saying, how central of a role do you think controllers have in the broader topic of app operations? I actually think that controllers like this, and I think, this was probably more work than it needed to be. I think, we need better boilerplate, we need better tools, we need better documentation around this. But I think this is, I think as we take common operations tasks and we work over time to really automate these things and package them up and share them, I think we start finding that these controllers like this become more and more critical. And we move from a sort of, one shot, run my tool to synchronize things to a continuous synchronization. And so in some ways, like we have the sort of the old way of shipping software, which is like, every 3 months we do a big build, we do a big test, we do a big push. And, and I think as folks move to a more sort of just-in-time, continuous deployment type of model, what you find is that you get some unintuitive benefits out of it, right? Because you're always shipping, your quality bar is always high. And it's kind of a chicken and egg type of thing. It's like you can always ship because your quality bar is always high, and your quality bar is always high because everybody knows that you can always ship. And it's a kind of a weird inversion and a sort of unexpected result that happens out of that. I think something happens similarly when your operations become continuous also. Because when you have automated code that are doing your synchronization, doing your operations task, what you find is that you don't have any surprises because the result ends up being oftentimes very close to the action that you're taking towards the thing. And so instead of actually having, Puppet or Chef run once a day or once every hour, you have these things be continually updating almost immediately as you change things. And I think it sort of changes your mindset about how you do this stuff. So how central is it to the role of app operations? I think over time this stuff is going to become more common. I think as our tool sets get better, I think the tool sets, it's too much work to expect everybody to write a controller like this. And I think we're going to find that this stuff gets packaged up and reused. And so we'll find ways to actually sort of create reusable components and break this down into smaller pieces that folks can glue together. So that would be my prediction there. All right, so we pushed this. So this is actually just up on the Docker hub. So now I can go through and I can do kube control. And obviously, if you're doing this for real in production, you'd want to check in, create manifests and check them in and stuff like that. But I can do kube control run image equals blah. Oh, TGIK controller. Now this is going to fail. And the reason why this is going to fail is because I'm running on a cluster with RBAC. So if I look at kube control logs, TGIK, if I look at this, it says, oh, failed to list blah, 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 cannot list secrets. So that's because That's because by default, when you're running on a cluster with RBAC, your service accounts don't have any permissions to do what you need them to do. And so I think we're going to run out of time. This might be a good thing to pick up on in terms of sort of RBAC in practice. So there's a couple of things here is that we want to create an RBAC role for this thing. Unfortunately, we need to give it access to all the secrets across the system, and so that it can actually watch and write those things. So this is going to be a fairly powerful controller in terms of the scope of what it can do. From a sort of security point of view, that's not great. But the fact that this isn't taking sort of user input from like random people on the internet means that the scope of people being able to compromise this stuff is going to be a hell of a lot smaller. There is the fact that a controller like this needs broad permissions to sort of muck with secrets across the entire system is giving a lot of people in the community heartburn. And so it's definitely something that applies to things like Helm. It applies to ingress controllers because they need to be able to read secrets across namespaces for TLS certificates and stuff like that. And so there's a lot of discussion about sort of how do we actually scope this stuff down a little bit. Yeah, so I think I'm going to leave it at there. I'm going to take the code that I have now. I'm going to check it in. Y'all can build it and work with it and muck with it a little bit. And I think what we'll probably end up doing is revisiting this at some point, maybe not next TGIK, but some future TGIK about sort of how do we deploy this and how do we actually start looking at RBAC. There is a project that folks have started talking about, which is looking at, it's difficult to get the audit logs right now, but looking at audit logs out of Kubernetes and using that to essentially create suggested RBAC roles so that you don't have to sort of sweat the details. You can look at sort of like, oh, this thing's trying to do this, it's getting denied. Let's scope the role so that it actually allows that thing to do the thing that it's trying to do. So when you're running in a known good situation, you can kind of grab a profile, apply that, and then be off to the races. So that's kind of exciting, sort of cutting edge stuff that folks are talking about. There won't be a TGIK next week. The entire Heptio company is going on an offsite. And so we're going to be going to this small Bavarian village outside Seattle called Leavenworth. And I believe that we will be drinking beer. And I hear that there's a Nutcracker Museum. So I'm really looking forward to the Nutcracker Museum. But I'll be returning after that. So thanks for tuning in. I know we were slogging through some pretty heavy duty stuff, but I'm really happy to get this out of the way. And I'm definitely going to take this stuff and clean it up a little bit and probably turn it into a blog post, which will be a lot more consumable without watching a bunch of these episodes. But you all saw how the sausage gets made, so that's kind of fun. So, all right, next time on TGIK, I'll probably be returning to a higher level topic. I don't know, I have a backlog that I have to look through. So if you folks have suggestions on stuff that you want to see me cover, more from the user perspective versus the coding perspective, that's probably what I'm going to be returning to next time. So thank you so much for watching. And, as always, reach out on Twitter, send me email, what have you. I'd love to hear what you think. Leave comments in the YouTube channel, and I'm going to keep doing these. So, all right, everybody have a good weekend.